Hello students, welcome back in this tutorial video. Here's me, Daisyschool, science teacher of Daisyschool. Today I am here with the remaining part of pressure lesson of class 7 and 8. In previous video we have discussed about the atmospheric pressure, etc. And today we are going to discuss about liquid pressure. Liquid pressure, factors on which the liquid pressure depend. Similarly, some properties of liquid pressure and some numerical problem related to the liquid pressure, density, relative density, and sinking and floating of object, which depends on the density of object. Okay students, let's enter to the topics. Liquid pressure. In atmospheric pressure, we have discussed pressure given by the atmospheric air on the unit surface of the earth. While defining the pressure, we have defined force acting normally on the unit surface area or force per unit area, that is called pressure. Similarly, liquid pressure means pressure given by the liquid on the surface of containing vessel. Okay, pressure given by the liquid on the surface of containing vessel. Surface of containing vessel means on the side of the wall of the vessel, at the bottom also it exerts the pressure. That's why simple definition, liquid pressure means pressure given by the liquid on the surface of containing vessel. Okay, pressure given by the liquid on the surface of containing vessel. SI unit same as the pressure other we have discussed already, Pascal. Pascal is SI unit, liquid pressure also. But to calculate the liquid pressure, we have to use the relation P equals to dZh or dRg. Okay, dZh or dRg. This is the relation where D means the density of liquid, H means depth or height of liquid, G means acceleration due to gravity. And in exam, frequently asked, prove that P equals to dZh. Okay, frequently in your exam, frequently asked, prove that P equals to dRg. So now we are going to prove the relation P equals to dRg. Okay, look at here. It's a vessel, let's say vessel or beaker, you can say beaker. Here we have used or we have kept certain liquid having density D. Its cross-sectional area of this bottom surface area is A. Height of the liquid, this height of the liquid is H. Let's say, okay, let's say D is the density of liquid, H means height of liquid, and A means this base area, we say cross-sectional area, okay, of the beaker. So, by the definition of pressure, we have already discussed P equals to F by A. Yeah, you know this relation. P equals to F by A, force per unit area. Okay, and force is the weight, also we can say force is the weight, and weight is the product of mass and we say acceleration due to gravity. Product of mass and acceleration due to gravity. That means weight of my body. Weight of my body means mass of my body times acceleration due to gravity. We can calculate the weight. So here instead of F we can write mg by A. Why? Because F means mg. Force is weight, okay? Force is weight. So you can write W equals to F equals to mg also. Actually, weight is the force, and force means mg. M means mass, G means acceleration due to gravity. Acceleration due to gravity, G. So product of mass and acceleration due to gravity is the weight of the body, is the force of the body on the body. So P equals to mg by A. Again, or P equals to density. Do you know density? I think you have read in the class 6 also. Density means mass per unit volume. Yeah, density means D equals to mass per unit volume. Then mass equals to cross multiplication D into V. Okay, D into V. From here Density means mass per unit volume. Mass means density into volume while doing cross multiplication. That's why instead of this m, we can write d times v, d into v. Why? Because density means mass per unit volume and mass means density into volume. That's why instead of this m, we can write density times volume. So m means d times v times g by a. Okay, m means d into v, g a. Why? Because density or mass means density into volume. Okay, mass means density into volume. Similarly, P equals to D times D means volume. Volume means length into breadth into height. Okay, length into breadth into height is volume. So you can write B means L times B times L times G. Here A, area means L into B. Area formula you know, L into B. So L times B. This L cancel. This B cancel. Then remaining terms P equals to D at G. Okay, remaining terms D at G. L, B, both are cancelled. So remaining term D at G. D at G, which is our required relation. Okay, which is our required relation D at G. Where D means density of liquid. Density of liquid. S means depth or height of liquid. Height of liquid. And G means acceleration. Acceleration due to gravity. Acceleration due to gravity, whose value you can use up to class 8. You can use 10 meter per second. Okay, you can use the value of G 10 meter per second up to the class 8. So we have proved P equals to dg, as it means liquid pressure depends on these three factors. Liquid pressure depends on these three factors. They are density of liquid, depth of or height of liquid, and acceleration due to gravity also. Okay, acceleration due to gravity. It means density of liquid means density of water is 1000, density of mercury 13,600. So pressure given by the mercury is more than that of the water. Yeah, because density is more of the mercury. That's why. Similarly, depth or height of the liquid. So pressure at the 1 meter depth and pressure at the 7 meter depth, which one is more? At the 7 meter depth, there is the more liquid pressure. When the depth increases, the liquid pressure also increases. Okay, we discuss later about this again. Acceleration due to gravity on the earth, approximately we use 10 meter per second. But when the heavenly body changes, when the altitude maximum height, at the maximum height, there will be the less acceleration due to gravity. At that time, little bit changes. Anyway, after the class 8, we have to use 10 meter per second. So you can use the same value, acceleration due to gravity. Okay, after this we are going to discuss about the properties of the liquid pressure. Okay, properties of liquid pressure. Similarly, same these factors we are going to discuss. So here, first property is liquid pressure increases with its depth. First property is liquid pressure increases with its depth. Okay, here we are going to discuss liquid pressure. First properties. Okay, properties of liquid pressure. Properties of liquid pressure. First point, liquid pressure increases with its depth. It means P directly proportional to X. Liquid pressure increases with its depth. So to prove this, we can do the one activity, one experiment. Let's hear. It is one bottle, plastic bottle. For this purpose, we have to make the hole at the three different height from the base of the bottle. Okay, let's make with the help of compass needle. We can make the hole. Okay, I have made one, second, third. So I have made here 3 holes at the different height. Okay, at the different height from its base. Now I am going to pour the water. Okay, Suresh sir is helping me. So we are going to show when the depth increases, liquid pressure also increases. Okay, so look at here. You can see from the top hole, liquid is falling nearby the bottom. From the second hole, it is covering a little bit more distance or longer distance. And from the bottom hole, it covers the longest distance. Why? Why? When the depth increases, liquid pressure is also increases. It proves that when the depth increases, liquid pressure also increases and covers the more or longer distance. But why? Why it covers the longer distance? Because for this hole, only this much water, this much mass of the water is exerting the pressure. For the second hole, this much water exerting the pressure. From the bottom hole, this whole water up to this water, this amount of water is exerting the pressure. That means when the depth increases, more amount of water is exerting the pressure. When the depth increases, more amount of water is exerting the pressure. Due to more mass, that creates the more force. And when the force is more, pressure also more. That's why at the more depth and covers the longer distance. But from the top hole, with the less mass of water is exerting the pressure. That means there is the less pressure. Due to less pressure, it falls nearby the bottom, which proves that liquid pressure increases with its depth. Okay, liquid pressure increases with its depth, because when the depth increases, amount of water also increases, and more amount of water gives more pressure at the bottom hole, because of which the water that comes out from the bottom hole covers the longer distance or longest distance than the remaining upper 2 holes, which proves that liquid pressure increases with its depth. Okay. By this relation, or using this fact, base of the dam is made wider. I think you have seen at the base of the dam nearby the river. Yeah, you can see nearby the river there is a dam, and base of the dam is made slanted and thick at the bottom. Why it is made wider? Why it is made thick at the bottom of the dam? Do you know? Yes. At the more depth of the water, there is more liquid pressure. Yeah. At the more depth of the water, there is more liquid pressure. And to withstand this high pressure, to hold this high pressure, to control this high pressure, base of the dam is made thicker at the bottom. But at the upper layer, higher layer, there is a less liquid pressure. Yeah. There is less liquid pressure, because of which thin wall also can control the pressure of the liquid. That's why base of the dam is made wider. So frequently asked in your exam, why base of the dam is made wider? This is the reasonable question, frequently asked in your exam. Why? At the more depth of the liquid, there is more liquid pressure. At the more depth, or at the bottom of the river, at the bottom of the this pond, there is more liquid pressure. And to control this high pressure, thick wall is made, but at the top there is the less liquid pressure, and less liquid pressure can be controlled by using the thin wall also. So it is made thick at the bottom and thin at the top of the dam. Okay. Similarly, another one is liquid pressure is equally transmitted. Liquid pressure is equally transmitted in all sides in the enclosed space. Okay, in the enclosed vessel, liquid is transmitted equally in all directions. Equally in all directions, which can be proved by using the another activity. So I have taken one polythene bag here. I have made the number of holes by using the compass needle. So here is okay. So when I press from the top, you can see water is coming out from the all sides, yeah, and pressure is equal. Pressure is equal because the liquid exerts the pressure equally in all direction. Okay, liquid exerts the pressure equally on all direction in an enclosed vessel, but in an open vessel, it doesn't happen like this. Okay, it does not happen in open vessel. In open vessel, at the same height, liquid pressure is equal. In the open vessel, at the same height, liquid pressure is equal. But in enclosed vessel, liquid pressure is equal in all sides. In all sides, in the enclosed vessel. Okay, and next one is a liquid maintain its own level. Okay, liquid maintain its own level. So to discuss this, we have to use one type of tube. We say Pascal's tube. Okay, Pascal's tube. Pascal's tube means having the different shapes. Having different shapes of the tube is connecting in a single tube like this. So here I have made 4 different shapes of the tube. Okay, it is completely vertical, it is a little bit slanted, it is look like a cross shape, it is a little bit curved shape. So different shapes of the tubes are connecting in the single horizontal tube. Yeah, single horizontal tube. If we pour the water from here, okay, if we pour the water from here, then first of all water is collected in this horizontal tube. After that, it starts to raise up inside the tube. But look at here shape of the tube, size of the tube are different, but level will be same. Okay, whether it is a little bit flat, it is a little bit small, yes, slanted, straight, but upper surface of water cannot be zigzag. It is in equal height, equal level. So if we pour the water up to here, let's say here, then straight to this, here also we can find the water. Here also we can find the water. Here also we can find the water up to this level. If you pour the water up to this height, then in each tube you can find the water in the same height. Although it is a little bit wide in shape, but the height of the water will be the same. Although it is a small tube, it will not be at the top. Height or level will be same. It means liquid maintain its own level itself. Okay, liquid maintain its own level, upper surface level itself. It cannot be at the high level at one side or one place and low in another place in the same tube. So this is called a liquid maintain its own level. This is the third property. Second property is liquid pressure is equally transmitted to all sides. We have discussed with the experiment or activity. These are the properties of liquid pressure. So now we are going to discuss about some numerical problems. Numerical problem also will come in your exam. That's why we have to discuss the numerical problem related with the P equals to dx relation. So let's discuss numerical problem. Okay, numerical problem. Let's say question number 1. Calculate the pressure at the depth of 7 meter of a pond. Okay, here is question. Okay, calculate the pressure or liquid pressure at the depth of 7 meter of a pond. So we have to calculate how much pressure is exerted by the water at the 7 meter depth of a pond. So here, okay, solution. Here we have depth means yachts. We have discussed already. D means density, yachts means height or depth of liquid, G means acceleration due to gravity. Okay, D means density of liquid, yachts means height or depth of liquid, G means acceleration due to gravity. So yachts means the depth of the liquid, which is given 7 meter. And remaining two terms, other nothing given in the question, but we have to know this. We have to know. Yeah, density of water. In pond there is water, and density of water you have to know. That is the standard value. Whether in the question there is mentioned the density of water or not, but you have to know this. Okay, if not mentioned, then you have to write yourself. Density of water is 1000 kg per meter cube. Yeah, 1000 kg per meter cube. So D means density of liquid, that is 1000 kg per meter cube. You have to know this. Okay, if not given in the question, you have to write yourself. Similarly, G, acceleration due to gravity, I have discussed already. Value of G is 10 meter per second per second. So 10 meter per second per second. Then liquid pressure P equals to what? We know the relation. Liquid pressure P equals to D as G. So density how much? 1000. Height or depth 7 meter. Acceleration due to gravity 10. So 7 ones are 7. 7 ones are 7. So 7. How many 0? 1, 2, 3, 4 0. 1, 2, 3, 4 0 unit pascal. This is the liquid pressure. So 70,000 pascals pressure is exerted by the water at the 7 meter depth of the pond. We can calculate like this. Okay. Similarly, another one. Another question. Let's say question number 2. It's a, let's say, tank or tube having 4 meter height. Okay, it's a tank or tube having 4 meter height, but it is half filled with water. It is only half filled with water. Let's say this is 2 meter. This is 2 meter, half filled. Now calculate the liquid pressure at the bottom of the tank. So here, similarly, yes, depth of the liquid how much? Depth. Total height of the tank is 4 meter. Gap is 2 meter. That means it is a half filled only. 4 meter complete height, empty space 2 meter. That means height of the liquid is 4 meter minus 2 meter. That is 2 meter. Half of the 4 meter is 2 meter. So you can say 2 meter. Height is 2 meter. Don't forget. Okay. We need only height of the liquid, not height of the basin. Only we need height of the liquid, depth of the liquid. So it is 4 meter height, but tank is only half filled. That's why we have to use 2 meter, half of the height. Similarly, density, you know, density of water, this is water, let's say, water, density of water same, 1000 kg per meter cube, and acceleration due to gravity, that is same, 10 meter per second per second. So pressure equals to what? We know that. We know that P equals to dgx. So here D means 1000, G means 10, H means 2. So 2 ones are 2 ones are 2. How many 0? 1, 2 Pascal. So 20,000 Pascal. In this way, we can calculate the simple numerical problem related to the liquid pressure. Okay. Remaining from the exercise, you can practice at home using the same lesson P equals to dgx. Okay, at home. Now Now we are going to discuss about the density. Okay, density. Density means, in class 6 also you have read about the density. Density means how heavy is the object. Okay, how heavy is the object. So this is the wood duster. So how heavy is this? If I take equal size of the iron piece, then what do you think? It will be heavier than this duster or less? Surely heavy. So how heavy is the object? If you feel that is more heavy, that has more density also. If you feel that is the light, then that has less density also. So heaviness of object is related to the density. Okay, related to the density. Actually, density means mass per unit volume. Mass per unit volume. In unit volume, in 1 meter cube volume, how much mass is can be occupied, can adjusted, can accommodate there. We can calculate by the density. So 1 kg in 1 meter cube volume, how much mass of the cotton can be adjusted, can be kept. Similarly, how much mass of iron can be kept at the same volume? What do you think? Which one will have the more mass? 1 meter cube volume of iron or 1 meter cube volume of cotton? What do you think? Surely iron will have the more mass because iron has more density and cotton has less density. So in 1 unit or 1 meter cube volume, how much mass is adjusted there, we can keep there. According to this, we can determine the density also. If that occupies that adjusted less mass, then less density, more mass, then more density. Comparing like this, we can find the density. Okay, so density means mass per unit volume. Density means mass per unit volume. So D equals to m by v. Density means mass per unit volume. So unit of mass is kg, unit of volume is meter cube. So SI unit of density is kg per meter cube. Okay, SI unit of volume is kg. SI unit of density is kg per meter cube. SI unit of density is kg per meter cube. Kg per meter cube. Then CGS unit, mass CGS unit gram and volume CGS unit cm cube. So 1 gram per cm cube. Gram per cm cube is the CGS unit of density. Remember, density of water. Density of water. That is the standard density we say at 4 degrees Celsius. Density of water is 1000 kg per meter cube. 1000 kg per meter cube, it means 1 gram per cm cube. Okay, 1000 kg per meter cube means 1 gram per cm cube will be. That's why don't forget this relation. Density of water, you have to know whether given in the question or not, but you have to know, you have to use this yourself. For other liquid, for other substances will be mentioned in the question. But for the water, to the standard one, you have to know this. That's the density of water is 1000 kg per meter cube, 1 gram per cm cube. Okay, 1 gram per cm cube. And density of object. Density of object. If density of object is more than density of water, if density of object is more than density of water, density of object is more than density of water. At that time, object sinks. Object sinks in the water. If the density of object is more than density of water, then object sinks inside the water. And if density of object is less than density of water, then at that time it floats. At that time it floats. If the density of object is more, sinks. If the density of object is less than water, then it floats. So compared to the density of water, we can find the this object can float or sink. Like ice. Ice is made of water. When we condense, when we freeze the water, it changes into ice. But ice floats on water. Ice floats on water because density of ice is 920 kg per meter cube. Density of ice is 920 kg per meter cube. You know, in your home there may be the refrigerator. Take one glass, completely fill with the water and keep in the deep freeze part. Yeah, and next day when you find that this water changes into ice, you can see volume of ice is more than that of the water. You have kept the water only up to the brim of glass, but ice level will be more than that of the brim of the glass. That means volume will be more in the ice. Ice has more volume than same water. That's why when the volume is more, density will be less. Okay, inversely proportional. When the volume is more, density will be less here. That's why density of ice is less than water. Density of ice is less than water. Only 920. Okay, ice density 920 kg per meter cube. So already we have discussed, if the density of object is less than density of water, then that can float. So density of ice is less than water. Density of water 1000, ice 920. That's why ice can float on water. Iron density is 7860 kg per meter cube, or 7.86 gram per cm cube. Yeah, it means 0.92 gram per cm cube. So 7.86 gram per cm cube or 7,860 kg per meter cube. It is more than density of water. That is 1000 only. So iron has more density than water density. That's why iron sinks in water. Stone sinks in water. Okay, why stone sinks in water? Because density of stone is more than water. That's why it sinks. And you can say piece of the wood, similarly a rubber, similarly petrol, diesel, yeah, on the water it floats. Why? Because they have the less density than water. Which has more density sinks, which has less density float. On the basis of this we can find. Okay, that is related to the density. Another one term is remaining here, relative density. Relative density means, actually relative means comparative. With respect to water, how many times density of the object is more or less? That we have to compare. So relative density can be defined by the definition. Relative density means density of object by density of water at 4 degrees Celsius. At 4 degrees Celsius we say, because density of water is a maximum at 4 degrees Celsius, and that is the 1000 kg per meter cube. Okay, density of water is maximum at 4 degrees Celsius, that is 1000 kg per meter cube. That's why here we mentioned density of water at 4 degrees Celsius. So relative density means actually comparison. How many times more or how many times less density of the object than that of the water we are going to compare. So relative density means you can define ratio of density of substance to density of water at 4 degrees Celsius. Ratio of density of object to density of water at 4 degrees Celsius, that is called relative density. Okay, like density of iron. What is the relative density of iron? Relative density of iron means density of iron. Iron is 7860 over density of water. Density of water means 1000. So how much? 7.86. Has no unit. Okay, no unit. So relative density is only 7.86. While dividing this, you can get 7.86. So no unit. Why? Because it is also density. It is also density. Unit of density will be cancelled here. So no unit here. It are the ratio of same physical quantity. That's why. So sinking and floating, we are going to discuss one activity. Like here is one glass. Filled with water. Here is an egg. In the clean water, let's check, it will sink or float. Egg sinks in pure water. Egg sinks in pure water. Why? Because density of egg is more than pure water. Density of egg is more than pure water. That's why it's changed. Now let's check. Okay, once again. So again I have taken here water. After that here is common salt, table salt, which is used in our home, table salt. So let's put some salt in it, in the water. Now I am going to make salt solution. Okay, salt solution. Salt solution is. Okay, now I have made salt solution. Again, put this same egg in this salt solution. It will sink or float. Let's check. So you can find egg is floating. Okay, egg is floating in the salt solution. Why? Why egg is floating in the salt solution? Because density of egg is less than salt solution. After adding the salt in water, density increases. After adding the salt in water, density increases. Because now compared to the density of egg, density of salt solution became more. And when the density of object is less than density of liquid, at that time object floats. So here density of egg is less than that of the salt solution. That's why egg is floating here. Okay, egg is floating here. So we can determine like this way. If the object has less density, then floats. If the object has more density, sinks. Okay students, how do you feel? If you have any question, then don't forget to comment in the video also. You can ask in Facebook also. So like it, watch it, comment it. Thank you.